Hi, so I'm here with Kevin Fall at the Computer Science Conference at the Symposium on Operating Systems Principles. I was really lucky to run into him here, and so I thought that actually hearing a bit about what he has to say about the internet would be interesting. So, Kevin, you're currently the author of TCP IP Illustrated. So, how did that happen? Like, what's your relationship to TCP IP and the stuff that you've done in the past, and what's your background with TCP IP?
So I guess when I was right after I graduated, and shortly after I got to Berkeley, somebody demonstrated to me that they could send some packet to Europe and back to Berkeley in under a second. I thought networking became sort of an interesting thing to look at. Fast forward a number of years, I worked on the networking implementation in Berkeley Unix on a Cray. Actually, for a while, that got me into a little bit of the HPC community. But then I worked at Lawrence Berkeley National Lab after my graduate work at UC San Diego. So at UC San Diego, I was doing some protocol work and some operating system work. But then with the networking group at LBL, that was all quite a bit in the networking side, and worked on network simulators and the NS simulator and so on. What happened, though, is I got to know this stuff pretty well, and by the early 90s or sort of mid-90s, when the internet was becoming more widely known, people took an interest in this, what is this TCP IP stuff? And this particular book, TCP IP Illustrated, was the standard reference text, and the volume one is still quite a good book. I was teaching out of it, teaching sort of professionals from industry, Cisco and places like that. And so I got to know the material quite well, but as the years went on and on and on, there were things that it would be nice to be updated in that book. And so I had been at places where I had heard some people were approached to rewrite it. Other people approached the editor, or Addison, to rewrite it. And for whatever reason, it never happened. So I threw in my table of contents and sample chapter and got the job, and some 7 years later finished off the entire task with something that's over 1,000 pages long.
Well, so what's an example of something that you thought sort of a change which needed to be introduced but wasn't in the original?
One of the major ones is security. So there's I think 100 pages of security that goes through the introduction of what are the sort of basic primitives, what are the sort of things you might want to protect against, and then all the various details of the protocols that actually does that. Really, security, not only the cryptographic parts of security, but things like firewalls and stuff really barely existed when the first work was done. There's also a new chapter at the beginning is sort of the architectural underpinnings, which is what was in the minds of people when they were thinking about how the design decisions about this sort of stuff was made. Because I always found that quite interesting, and being an operating systems guy originally, how people came up with abstractions and how programs access those things, and not quite users necessarily, but what are the sort of architectural concerns. And so I always was quite interested in papers and thoughts in sort of the architectural area.
So last night we were talking, and you said that there is today people use the terms datagram and packet interchangeably, but those were not interchangeable terms. They actually meant something quite different, which now is sort of lost in the...
Sort of lost in time.
Lost in time, yeah. So you want to talk a little bit about that?
So I think I mentioned this in that part of the book, but packets were sort of a fascinating new concept, right? That you could divide your larger messages into little parts and move them around the network. But they were originally, at least some variant, were as part of virtual circuits. And so, for example, the destination in a packet was the destination of an index in the table of the next hop. So you would sort of set up the route ahead of time. And then if that failed for some reason, you'd have a bunch of work to do to sort of go back. And there's all the history of circuits and so on. But datagram was a maybe even more radical idea in which the destination, the final destination is identified in the packet sort of structure, which the way when I would teach out of this class would say, if I laid out the network in a two-dimensional space with this datagram type property, I could take it and drop it from the air down onto any router, and it would just find its way through because the final destination is listed, but of course that was a trade-off because now you have more bits that you have to allocate because there's presumably a larger number of possible destinations that might be available. So these were the kind of nuances that were actually pretty neat to sort of get the details from by going back in the architectural history and thinking and learning about what people were sort of arguing at the time.
Cool. So what are you working on now? In the sense of like, what are the sort of the most interesting things do you think in networking and the internet and systems that that you're trying to tackle?
So there's a couple areas that I think are fun and sort of worth mentioning. At least one of which we have some work on. The first one is just we don't have so much work on, but is the and I mentioned to you Licklider, and I make reference to that in the book as well. But the him and some sort of his colleagues and predecessors had envisioned that not only do we have a thing that winds up essentially being today's internet, that there's communication in these communities, but there's also a physical way of moving things around, which was like a global pneumatic tube system. So you could, take your thing, shove it, and it would find its way, which would be a very cool thing to have.
Sure.
But I don't think we're quite there yet, and I'm not sure we're ever going to really wind up with that.
Maybe
yeah,
FedEx,
they sort of made it possible.
Not pneumatic, but
it's not quite pneumatic. But on the other hand, I think the sort of 3D printing technology, as combined with what's going on with the sort of free or easy dissemination of information, becomes quite interesting, especially when you can put things other than plastics and so on. So I had in my hand a demonstration. It was a titanium 3D printed nose replacement part, prosthetic nose, and it was strands of titanium printed on top of each other. And if you can load up your device with the right materials, pretty much any material thing you want to create almost could be created. So we've, even into the world of sensor networks, people looked at both sensing the world, maybe even actuating the world, but like building the world on demand in combination with those other things is pretty interesting. And I wonder if that's not kind of the way to get to the vision of pneumatic tubes, but instead of actually moving it, you just make another one.
Yeah.
And so that, how far in the future will it be that you just carry around in your car, your backpack, or whatever, the basic system, and then you just download whatever the thing is you happen to need. It even goes a little, there was literally, I think it was not a few months ago, there was a meeting in Washington, D.C. about like the security implications of additive manufacturing.
Right, I mean, there's all those questions about firearms.
Yeah, like printing guns and all that sort of.
AR-15 was a lower chassis. So generally in firearms, there's one particular piece of the gun that's the one that's strongly regulated. It's the thing which kind of everything has to stick onto. And somebody 3D printed one. It's normally something you need a license for. Sort of this interesting question about what then the implications are going forward. All these kinds of things like DRM.
Yeah, and so I think there's lots of policy questions. I think as is often the case, technology will outpace the policy ability to comprehend and sort of instantiate reasonable laws about these things, whatever that may be.
Yep.
And so this idea that bits that are become interchangeable with physical objects, and we have traditionally regulated the control of physical objects, but now do we have to
start measuring latency includes the creation time, right? There's the scanning and creation time.
It's pretty interesting. So that set of implications. So that's one of the topics, and actually it gets into other things that you can compute with, and maybe print and compute, like synthetic biology. I want to create a little organism that takes one thing and something comes out the other end. Well, if I have biologicals in my 3D printer and I can download that and have not just download designs, but have the tools to do the designs of the biological systems. There's all sorts of stuff, right?
Security is very concerned about these implications.
So that's one whole category, I think, that when I was thinking about the pneumatic tube system and then looking at 3D printing and its capabilities, and now the price has gone down so people can just go get them, this is a pretty interesting thing.
Cool. Well, it was great chatting with you, and thank you for your time.
Okay.
And
sure.
See you next time.